Alright, in this video we're going to look at factoring quadratics with a greater than 1. So yesterday we focused on factoring when a equals 1, and we know at this point in the year that factoring when a equals 1 is pretty straightforward. We're looking for two numbers that multiply to c and also add to b. We use those two numbers to directly factor the expression, and then to solve we set each factor equal to 0. So the process for factoring with a greater than 1 is kind of similar in the idea that we're trying to split it up into linear factors and set each equal to 0. But the process for doing this is a little bit more extensive. So these are kind of the steps we want to follow. We want to factor GCF if there is one, and we'll really just divide that out instead of factoring since we are solving equations. We're going to split the middle term into two parts, which means we want to split up b into two things that add to b. But we don't only want two things that add to b, we want those numbers to also multiply to ac. Then we're going to factor by grouping. So we'll look at two separate two-term expressions, factor each part, and then factor the identical piece out of those. So in our first example here, let's take a look at our equation. Notice that this is already in standard form, which is good. We're going to look for a GCF, but there's nothing in common between these three terms, so we're going to go right to splitting the middle. So we're going to split up this negative 14 somehow. We want to split it up specifically into two numbers that multiply to a times c. That's 3 times negative 5, which is negative 15. And we want two numbers that also add to b, which is negative 14. So we start running through our list of numbers that multiply to negative 15, like negative 1 and 15, negative 3 and 5, 3 and negative 5, numbers like that, until we notice that negative 15 and positive 1 actually are the two numbers that multiply to negative 15 and also add to negative 14. So that tells us that we want to split this negative 14 up into those two parts that we just mentioned. So we have 3x squared. We want to split this up into negative 15x plus 1x. And so we've split that middle term up appropriately in a way that will allow us to factor by grouping. So I'm going to focus on the first two terms right here. And out of these, I see that I can factor out a 3 and an x. So I'm going to factor out 3x. They have that much in common. Dividing this by 3x leaves us with x left over. Dividing this by 3x leaves us with negative 5 left over. So I'm going to copy down this plus sign, and now I'm going to look at our next two terms right here. I'm going to look for anything in common that I can factor out, and there is not anything, so I'm just going to factor out a 1. And factoring a 1 out of here, I'm left with x. A 1 out of here, I'm left with negative 5. So we haven't really changed anything. We just kind of pulled a 1 out. And now I see that these two have an identical factor of x minus 5, which means I can factor that x minus 5 out front and see that I'm left with 3x from the first term and 1 from the second term, 3x plus 1. And you'll remember that from here, our strategy is set each factor equal to 0 and solve, which means we have x minus 5 equals 0. I'm going to add 5 to both sides and get our first solution, x equals 5. 3x plus 1 equals 0. I'm going to subtract 1 on both sides to get 3x equals negative 1. And I'm going to divide both sides by 3 to get x equals negative 1/3. These are our two solutions. So again, we look for two numbers that multiply to AC and add to B, and we use those two numbers to split the middle, and then factor by grouping, factor the first two terms, pull a 3x out of here. Factor the second two terms, there's nothing in common, so we just pull a 1 out. And we should get this identical factor, x minus 5. That's what allows us to factor it out in the next step and see what we're left with. Set each factor equal to 0 and solve. Let's do that again with the next one. So anytime we're solving, finding x-intercepts of a function, we're thinking of setting this equal to 0. This is already in standard form, but we also want to divide out a GCF if we can. So the first thing I'm going to do is notice that 4 goes into all of these. So I'm going to divide everything by 4. and get 6a squared minus 7a minus 5. So it's in standard form, no GCF, and now I can start looking for two numbers that multiply to a times c, that's 6 times negative 5, negative 30, and also adds to b, which is negative 7. So I want to strategically split this negative 7 up in a way that the coefficients also multiply to negative 30. So we start running through factors of negative 30, like negative 1 and 30, 2 and 15, negative 2 and 15, or 2 and negative 15, until we realize that two numbers that do what we're looking for here are negative 10 and positive 3. These two numbers multiply to negative 30 and also add to negative 7. So this tells us that we're going to split that negative 7a up according to those two numbers. So we have 0 equals 6a squared, splitting the negative 7 up into negative 10 and positive 3. And now I'm going to look at these two separate two-term expressions. 6a squared minus 10a, and then separately 3a minus 5. Out of the first two, we can factor out, these have 2a in common. So I'm going to factor out, I'm going to factor out 2a, and I'm left with 3a here when I divide that out. And when I divide out 2a from here, I have minus 5. Out of these two, there's nothing in common, so I'm going to be stuck just factoring a 1 out again. And what I'm left with, of course, is exactly what's here, 3a minus 5. We know that we've done something right because we have this identical factor of 3a minus 5, so I'm going to pull that out and see that I'm left with 2a plus 1. And again, the idea behind doing this is linear factors. We can just set equal to 0 and solve. Add 5 to both sides and divide both sides by 3 and get our first solution, 5/3. Set the other one equal to 0. Subtract 1 on both sides and then divide both sides by 2. Remember that this only works assuming that our equation is equal to 0. So if the product, this times this, equals 0, then one of the factors must be 0. It's called our zero product property. Let's look at one more. So first of all, I want to get this in standard form, which means I'm going to bring everything onto the right side. So I'm going to subtract 12, and I'm going to add 4b squared. So adding 4b squared to this gives us positive 2b squared. We have minus 9b. And subtracting 12 from this gives us negative 35. So I brought everything to the right side and put it in standard form. I'm going to divide out a GCF if we have one, which we don't. That means I can start looking for two numbers that multiply to 2 times negative 35, which is negative 70, and which also add to b, which is negative 9. So we start thinking through factors of negative 70 until we arrive at negative 14 and positive 5. You can check that these two numbers multiply to negative 70, and they also add to negative 9. So that tells us now how we're going to split up this negative 9b. (2b squared). I want to split that into negative 14b and a positive 5b, minus 35, and this should allow us to factor by grouping. So I'm going to look at these two separate from these two. Out of those first two terms, we have a 2b in common, so let's divide out the 2b. We're left with b from the first term, and we're left with negative 7 from the second after we divide out that 2b. From the second two terms, these have a factor of 5 in common, so I'm going to factor out that 5, and notice that when I divide it out, I have b and minus 7 left over. So again, we've done something right just based on the fact we have this identical b minus 7 factor. That means I can factor it out from both terms, and I'm left with 2b right here, and I'm left with 5 right here. And of course, our last step is, because we now have linear factors, we should be able to solve these equations. We set each one equal to 0, add 7 on both sides to get our first solution, subtract 5 on both sides, and then divide by 2 to get our second solution. And so our two solutions are here and here. Remember that when you complete the classwork, you have to click Turn In up on the top of Kami when you're all done.